Speed up your existing relational databases with Speedment and Hazelcast. As Andreas said, my name is Per-Åke Winborg, and I'm the CTO and founder of Speedment. So I will talk a little bit about how Speedment and Hazelcast work together, and so you will be able to track all the changes in your existing relational database and automatically feed that into your Hazelcast maps. And it doesn't really matter how the database is changed, we will be able to track any change to change it anyhow. So our typical customer already have a database with a lot of data that they cannot change. Perhaps they've been using their database for several years, or maybe they don't want to migrate from it. Maybe they think it's good, but maybe it's not fast enough, but they like it otherwise. So then they can keep it, like if they have Oracle or Postgres or anything like that, solid database. So, and also in my previous webinar, which was the first webinar, obviously, since it's the second, you can read and see more about the more in-depth technical details. So this presentation will be kind of a little bit more overview of what you can do. And the previous presentation, you can see code and stuff like that a little bit more. Okay, so what's the problem then? Yeah, as you may be aware, the response times are one of the most common IT problems at work. People get frustrated when they have to wait, and business, they lose customers if their web customers must hang there and wait for response. And the amount of data is increasing every day. I mean, there are billions of mobile phones and millions and millions of browsers generating a lot of data, and all this data is important for customers and for companies, so they want to be able to analyze that. And what's the solution? I used to say, if there is a house and you have to fix it, if it leans like this, you can perhaps try to fix the ground, or you can ask the architect if he or she can fix it. Maybe ask the carpenter or even the painter. In Sweden, there is this saying that it's always the painter's fault that the house is leaning, because that person is the last who lay hands on the house, and thus he gets blamed. But I mean, in reality, it's not like that. But perhaps you have a database, and then you can ask the DBA to optimize the database. That is good. You can get some performance out of that, but only marginal. Or you can ask the hardware supplier. Maybe you can buy some new hardware. But the problem is that you often have to pay a lot of licenses in combination with that if you have a commercial database. Also, the hardware is relatively expensive and perhaps not scalable. So you'll get some performance, but even though not so much. You can change the ground. You can introduce a completely new database like MongoDB or Cassandra or any other NoSQL SQL database. NoSQL database, I mean. And then you can get extreme performance, of course, but then you need to migrate all your data and perhaps change your entire backbone and everything. So that's really a transplantation if you compare to just a mild cure. Okay, so we can instead target the application developers, like we might be, and that is where the Speedment and Hazelcast solution comes in. So we want to put the Java developer behind the steering wheel. We think this is a new hot solution, and it's very quick. It allows you to very rapidly develop your own application, and you get extreme database speed. So you want to be behind the steering wheel, and you don't want to be this snail crawling up here. So let's start with a technology overview. What is the trend in this area? So memory size grows exponentially. If you look at the history, you can see that in 1966, which incidentally was the year when I was born, you have to pay like if you want to buy 1 gigabits of RAM. I don't think there was really 1 gig of RAM available in the entire world, but theoretically, you have to come up with $512 billion to buy that kind of memory. If you fast forward to 1985, when I started university, you still have to cough up a hefty $1 million to get that kind of memory. But if you go to today, if we want to buy 1 gigabyte of RAM, that will set us back 1 quarter. So it's been a tremendous development, and there's no sign for this ever decaying or diminishing this growth rate. So eventually we'll get a lot of RAM in our servers. The thing is, it's almost the same with the CPU, even though the number of CPU cores is growing quite slow, and the performance is also growing quite slow. But together, it's also an exponential growth. So we want some kind of solution that scales with both memory and CPU performance. And certainly one of the trends right now is to be able to deploy things in the cloud. So these are kind of technical things. So that brings us to the shared database challenge. If you have Hazelcast and you write an application that only has Hazelcast, then that will work with the database, because every update you do to a Hazelcast map can be tracked, and Hazelcast can persist those changes to the database. And also, if you read something that's not really there in the Hazelcast map, Hazelcast will be able to intercept that and pick everything up from the database. And that is all well. But there might be that there are third-party applications that will update your database in parallel. And then Hazelcast map will not be aware of those changes. Perhaps you have a script, or perhaps you have something that goes out to the internet, downloads data, or you have a web application that feeds into the database. So then you can, of course, try to tackle this with different strategies. For example, you can export your data from the Hazelcast map periodically, and then when you try to read it again, Hazelcast will reread it from the database. But then again, that would be quite inefficient, because if you have 1 million entries, you have to export all 1 million entries. Is perhaps if just one single entry changed there, and that's very inefficient. Another way would be, of course, to invalidate what you have in the Hazelcast map, so that when you hit that, you can reread it again from the database. But that's basically the same, so that will lead to the same problem. And that's where Speedment comes into picture. Speedment is able to detect any changes in the database regardless of how it's done, even though it's scripts or triggers or even stored procedures. And it will sniff those up and calculate what it has to do to update the Hazelcast map, so it will exactly reflect the database content. So this is another picture. People will insert, update, or delete stuff in the database, and Speedment will just sit there and listen and feed those changes into the Hazelcast maps like this. So the information flow will go from left to right all the time. Okay, so how does that work? Yeah, in a relational database, you have, of course, tables that are related to each other. Whereas you see up here in the JVM, here we have the Speedment application, and it will contain directly or indirectly all elements that you have selected from the database that you want to work with. And it will contain not only all the objects, but also how they are related. So therefore you can get the data much quicker than you otherwise would have been able to do. So this is really a combination of three technologies. In-memory technology, which we probably heard a lot of lately, something called materialized object views, which are really a higher layer cache. It's not caching the objects as such, but it's caching the relation between the objects. And there's also something called separation between command and queries. So everything that goes in one direction goes in a separate lane, and everything at the right goes in the other direction. And of course that's more efficient, but then it's very tricky to keep everything consistent. But we have done that. So if we look at, for example, this is a MySQL example. If you insert something, in this example it's an employee, into there you will automatically see that very close in time in your Hazelcast map. You don't have to do anything, it just appears. And if you update something else, like this Georgia 2, then it will automatically fix that in your maps too. So it will appear there, and if you delete it, then obviously you will lose your mapping. In this example, we have mapped the primary key, which is the first value, and that is what is used in the Hazelcast maps. It even works with transactions. So in this example, you have a transaction with a guy with a funny name, and probably misspelled his name, and then they have to give him some compensation. So they do this in one transaction, and the thing is that this transaction will either be shown in both the Hazelcast map, or it will not be shown at all, so it will appear atomically in both the maps. And that is very important in some applications. So how to install it? Well, it's very easy. You download the software, unzip the distribution file, and you start a script in the bin directory. So it looks like this, the flow. You have a database. You start the GUI, Speedment GUI, and select tables and everything you want to use. And just click a button, and then you will import everything that's been generated into your favorite IDE like Eclipse or IntelliJ or NetBeans. And the generated code, there's a lot of generated code, but of course it will generate POJOs that you can insert in your maps, and also very efficient serialization factories, so that you get the performance you expect out of your Hazelcast data grid. It's very easy to integrate. You just add 4 lines of code in your existing Hazelcast application, and you're good to go. So if we see how this employee map looks, it's just a very simple table. The employee number, birth date, first name, last name, gender, and a hire date. And this is showing the existing database. And the next one of the example of the things that's been generated is this POJO. And of course, you can see here that there's a clear relation between these elements that are in the POJO and the database. They correspond directly to each other. And as you might see also, the POJO implements this identifiable data serial, which is an efficient way to serialize and deserialize your data across Hazelcast grid. So, how to use it? Really, it's very easy, as I said. Here is a more detailed explanation. When you start a project, you connect to your database, in this example MySQL, on my local host, and I just tell what kind of schema it is. And then it will discover what's in that schema and show me a graphical picture of each and every table. So I just select what I need and then press this button here, the play button, and then I get code. That's it, and then I can close my GUI and never use it again. So, how do you start coding with Hazelcast? Here you have an example of how to do that. It's very simple. It's just normally create a configuration, and then you have to add the bluish kind of line here is what you have to add. You tell Speedment here that you tell Hazelcast that you have to use the Speedment serializers, which is done really with one command. And then you say to Speedment that you have to use this Hazelcast instance. Then you build all your metadata that is needed from the database, and then you start tracking the database with this command at the bottom. So it's very easy to do. So that was the technical side of the presentation. So now let's go to some cases that we have. So there was this network operator that had a huge Oracle database with travel tickets, and they had more than 100 gigabytes of data, and it looks like this. They had a travel ticket system, and they have more than 100 people and subsystems that accesses this database every day, and it was a global player, so the sun never sets on the areas that it was serving, so it has to operate 24/7. And the interactive response times were really terrible, and sometimes the user had to wait for minutes before they were able to get response from the system. They had to disable some features like search. If they did that, they would totally choke the system, and it didn't work at all. They couldn't run batch job because if they ran them, the response times for the interactive users will be very poor. And basically all data was placed in a single table, and there was just a few supplementary tables like travel ticket type, subsystem, and status. A status is like if it's new, assigned, open, or closed ticket. So they have one active database and one hot standby at the main server site, and they also had a remote database located in another city far away that they used for disaster recovery if that was ever an issue, if there was some kind of catastrophe. The standby database was updated synchronously, whereas the remote one was asynchronous over VPN. And the clients were fat clients writing in Java Swing, so they were a bit oldish, but still it worked. And they communicate with application servers that ran a Tomcat web server. And the clients, they connected through a load sharer. So if one of the application servers were down for maintenance or down for any other reasons, they just reconfigure the load sharer so that the service will continue to run. And the users were, of course, not happy about this. Maybe they sat in a telephone and was trying to respond to some kind of error, and they had to search, is there a related issue? And then I had to wait for 1 minute, and they were very annoyed. So we came up with this solution. This is new system architecture. So whenever there is an update in the active Oracle database, it's like before propagated to the standby databases, but now also to Speedment. And Speedment will react to whatever changed in the database, and it will update the Hazelcast maps accordingly. So for example, if a ticket was changed from open to close, that ticket will be updated in the Hazelcast grid. And if a new ticket was created, that ticket will be created in the grid as well. So the application service now queries the Hazelcast grid instead of the database. So it sits there as an intermediary. So by reflecting all data from the relational database to the Hazelcast data grid with 6 nodes in this example, and using the Speedment org, we'll be able to reduce the query times so that they're mostly executed in sub-second time. Compare that to minutes, and you will get a picture what the improvement was. They can also re-enable the more advanced queries that they had. So now they only took maybe 2 or 3 seconds, and it didn't affect the other users noticeable. So they just open up these features again. And they think that the number of users will grow, and also the data will grow with approximately 8 gig per year. So they're planning to add 1 or 2 new nodes in the system in the coming year. So it's very easy to grow with this structure. You just add Hazelcast nodes, and your performance will go up, and your total storage will go up. And they didn't have to do any migration project. They can keep all their old data, scripts and analytics tools and everything. The only thing they had to change was the application service that served the interactive users. They had to be written slightly. So that's good. They can keep all their old scripts and whatever they had before. They will still run towards the database. And one potential opportunity that I have now is that they can reduce their Oracle license cost, because now the database is mostly idle. It's only concerned with updates now. It's updating from the users, which is quite rare compared to reading, and updating Speedment. So that the load is much lower than it was before. So they can get away by paying less and getting more, basically. So the second example is a sales organization which have their headquarters in Sweden. They have local national offices in 8 countries, and each country had in some countries more shops, in some countries not so many. And most national offices that have their own database. And in this example, we have something called extract, transform, and load, which is basically you take something from a database, do something with it, and you store it in potentially the same or another database. So this is something we're going to show here. So this is how it looked like. It was a Swedish retail brand that sell clothes. They had a headquarters in a mid-sized town in Sweden, and mid-sized in Sweden is less than 100,000 people, so it's not so big. And they have subsidiaries in 8 countries in Europe, and they had their own database. And they fed it automatically from their cash registers. So each country had live information on exactly what is sold and by whom. And every now and then, like each day or something, the local branches connects to the HQ and sends email of what's been sold, and then they process this manually. And sometimes they also call if there is something peculiar happening, like there is some star or something using their clothes, and suddenly they start to sell a lot of them. But apparently it was very important for the HQ to know what's hot on the market, because they have to balance supply with demand, and they don't want to have too much on stock. And I think they're manufacturing a lot of their things in low salary countries like Philippines and China. So they really want to cut down the lead times and be on top of what's going on. So we changed this to another structure. So this is the new system architecture where we have deployed Speedment on each local database so they can be tracked individually. Every change that is made to the local database is detected by Speedment, and it's then conveyed via VPN to HQ. The local Speedment instances are also some special adaptation to the data, so that the small differences in each country, the data format is not exactly the same, but they're converted to a standard format. And we also translate the name of the table, because usually the name of the table is sales in the local regions, but they are renamed to like Finland, Denmark, or whatever the countries. And if the VPN goes down, Speedment will resume where it left off once the link is up again. Now, at HQ, there is a log and MySQL database that receives all the updates from the local branches. The object of this is to be able to quickly react on what's going on different markets. So there's yet another Speedment instance that reflects the aggregate data to a Hazelcast grid. This grid contains all data from all countries in real time. So now HQ can get instant reports in real time. They will know down to hours and see in each shop to see what's cooking and what's popular. And one funny thing with this was that some of the local countries were using different databases. Like one had Postgres instead of MySQL, but that was not really a problem, because for Speedment it's agnostic what kind of database you have. It will translate anything to Java objects, and then you don't have to care about that. So they gained improved business intelligence. Third and lastly, there is a case of a power grid operator. It's again a Nordic country with a well-known electricity provider here. They had a large transmission networks with about 1,200 nodes, and these are larger nodes in the transmission net. And they have gathered data here from like 12 years and sent it to a central database. And they measure things like voltage, current, apparent power, temperatures, or whatever. They measure that for each hour. And more recently in these countries, there has been a new legislation mandating home meters that collect power usage in much shorter intervals, like down to an hour or so. But the company would like to measure even more granular than that. They would like to measure each 5 minutes. So the meters are gathering measurements, results regularly, and then after a while it contacts the central server and dumps all the measurements to a server. And this system is dimensioned for 1.3 million homes. But right now the number of modern meters are much lower, but it will rapidly become a lot of new meters out there. And there will be like 1.3 million transactions. And yeah, since there are 12 5-minute interval per hour, there will be an average load of more than 4,000 transactions per second. But in reality, the load is not even. For example, if there is a communication outage, there will be a kind of a storm when all the meters reconnect. So we have to dimension the capacity for much more than that. So there is a writer that sits. Everything that comes in is written to a file, and then the writer picks up that file again afterwards when it's been buffered, and it pushes everything into the database. And the database is used for many reasons. One is to be able to detect patterns in the electricity usage, so the company can learn about what affects consumption. So they can be progressively better and better to plan their energy demands, and they can make better deals on the Nordic electricity spot market. They would also like to offer the end customers to gain access to their own consumption so they can have an app in their smartphone and see how much do I consume in my house right now. Another thing the database can do is to compare the energy flow between 2 or more nodes in the transmission network to see how much losses there are. If you send out certain power from one and receive it slightly less from another, you can easily calculate what you're losing in transmission. But before, the database queries were very slow. Typically it took several minutes, so intelligence was basically conducted in a batch-oriented fashion with very long response times. So we did like this. Because the peak update rate from the database was so high, we selected to not detect the changes in the database itself as we normally do, but we instead harvest the data from 2 JSON files that the writer updated at the same time that it inserted data to the database. This is a solution we've done with several customers. So that required only a small change in the writer. But the advantage is that storms will not affect the Hazelcast grid. If we get a storm, then the database will lag substantially, but the Hazelcast grid will still be able to receive the updates much quicker. So they will get the most recent data. So now analysts can work with this with response time in just seconds. So they can work more interactively with the analysis, and it's much more productive if you can perhaps change a parameter, see what's happening, change another parameter, see what that happens, and so on. So the net increase was more than 100 times faster with this solution. So when the JSON files, they were rotated and dropped after a while, and the data grid became very quickly it became very huge. So what they do is after a while they reduce the resolution. So from maybe a few days you have the resolution down to 5-minute period, but after some days you only have per hour, and after a while they just purge the data. So historic data analysts, they still do in the database. Yes, and by the time more meters are adding, or if they want to keep more stuff current in their data grid, they can just add more Hazelcast nodes. So they can grow linearly and scale with this system. So that was my presentation. I hope you found it interesting. And now when I'm ready, take any questions that you might have. So the question is, in an enterprise scenario, and if you would like to have several Speedment JVM if one crashes, can you do that? And yes, you can do that. That was actually what we did in one of these cases that I showed. So the first case there, if they were actually 2 of them active all the time. So once there was a change in the ticket, it was actually picked up by 2 nodes and fed into the board. So if one goes down, then the other one will still be able to operate, and there is nothing preventing you from having 3 or more reflectors up and running at the same time. So you can certainly do that. Next question is, does the full data set always have to fit into the Hazelcast grid, and is it fetched eagerly? Yes. Yes, the simple question is yes. You have to have it in memory, otherwise you have to do something special that you might look for it first there and then maybe load it from the database. That can be done fairly easy, but in principle it's fetched eagerly. And how much can you then load? If you start an application and would like to load an entire database or an entire table eagerly, it might take 1 minute or so. But in the deployment we've seen before, then just a query will take a minute. So although it takes you some time in the beginning, it's still, in the long run, something that you will benefit a lot from. Next question. In the Power Grid example, do we need a Speedment between Hazelcast reads back to the DB if the power users update their profiles back to the DB? Okay. Mm, I understand what you mean. You can use a Speedment if you want. There are persistent means that you can use to update the database if you want, but you can also use like JDBC connection or scripts or whatever you need. It doesn't matter really how you update. There are some very simple means to use it. Use the Speedment. It's Speedment. It's more than a Reflector. It's an ORM. So yes, you can use it. You can just change some values, and you can just basically do update on it, and that will be persisted to the database, sniffed up, reflected, and back into the Hazelcast grid. Next question: how long is the delay between a database update and until the map is updated? And the general question is 50 milliseconds. That's the normal average delay, because we will harvest what's been changed regularly there. This is something you can set. So if you want to have lower latency time, you can set that. But then, of course, at a certain cost, you will hammer the database a little bit more. But that is the usual case. So 10 times per second, we will see if something has changed and act upon that. If a Speedment, next question is, if the Speedment node goes down, does it pick up from where it was before it crashed? Yes, it does. It has a kind of a transaction log, you can say, that's processed. So if the node for any reason goes down, it will start off where it was before it crashed, or if it was brought down. So you will not lose any data, but you will not update your data grid, obviously. But once this is resumed, you will fast forward to wherever you are right now. So you can say that the Hazelcast data grid is eventually consistent in this sense. Next question is, what database types are supported? And the answer is that we support most common database type like Oracle, MySQL, Postgres, and also some more exotic databases like MongoDB or have recently implemented. If you don't see the database you're using, we can certainly fix support for that, because it doesn't require any specific SQL support. It just relies on standard JDBC features. So I think we have support now for 5 or 6 different of the most common databases, and if you run across a new one, we will do them on a need basis. Is Speedment a single point of failure? This question is related to one of the other questions, and you certainly can deploy it in a high availability scenario where you run several Speedment instances. If you just run one, the answer is yes, then it's a single point. But if you run 2 or 3, then you have redundancy in your replication. So I would certainly recommend to use at least 2 in an enterprise environment. Does the database schema change force an application restart? It depends, I would say. It depends. You can change the database schema if you want, but if you add a field that you also want to be able to act on, we're working with a standard Java POJOs, so you have to then regenerate those POJOs so the new field is seen if you want it. But if you don't want to use it, you can just add. If it's not in the POJ, you can add and remove them how at will. It doesn't matter. But if you want to use it in your application, you must regenerate the POJOs so they reflect the Java model that you are using. How big data sets are supported? Okay, that is really the question. How big data set does Hazelcast support? I think Hazelcast has ran scenarios with over 400 nodes, so I guess you can run huge data sets that are really not only limited by how many nodes you can afford. So you can shard your data over nodes, and you can set data affinity so that data that's related to each other will end up in the same node. So you can have really, really big sets if you want. And that's all question. Okay. Thank you very much, Andrea, and I will hand over to you.